Hi students, I hope you have tried out this question 1 on page 91 of your workbook. So let me go through with you, just in case some of you are stuck at certain parts. So let's look at this geometric figure here. So in this case, these are squares. So they say in figure 1 and 2, these are the corresponding length of sides of large square. So let me tell you what is a large square. So this is called the large square, the largest square. And when they say that the number of gray square, what does it mean? It means the one, this is called a gray square, the one is inside. And when they say the number of white unit square, which is the white color one, so these are the unit square. And the total number of unit square will be all the small square you found inside this large square. So for figure number 3, right, let's fill up the table. So they say the length of side of large square for figure 1 is 2. So it means I have 2 square. So I write 2. So for figure 2, I have 3 square. So I have to write 3. So for figure 3, it will be 4. Because I got 4 square. And figure 4 will be 5. And for if I have figure number n, what do you think will be the length of side of large square? So if you notice, right, when it's figure 1, my length of side of large square will be 2, which is 1 plus 1. Figure number 2, which is 2 plus 1, which is 3. Figure number 3, which is 3 plus 1, which is 4. Figure number 4, which is 4 plus 1, which will give me 5 for the length of side of large square. So for n, right, when my figure number is n, it will be n plus 1. Because I'm always adding 1 whenever I want to find out the length of sides of large square. Also for the number of gray unit square, when it's figure number 1, I notice that the number of gray unit square is 1. For figure number 2 is 4. For figure number 3, in this case is 9. For figure number 4, in this case is 16. And what do you notice about these numbers over here? Do they ring a bell to you from what we have gone through in the previous example? So you notice that these numbers here, they are called square numbers. So 1 is 1 square. 4 is 2 square, 2 times 2. 3 is 3 square. Okay, so let me write this number below so that you won't be confused. So 1, let me write it aside. So 1 equals to 1 times 1, 1 square. 2, 4 equals to 2 times 2, equals to 2 square. And 9 equals to 3 times 3 equals to 3 square. 16 equals to 4 times 4 equals to 4 square. So let's check for the figure number, right? Does it has any relation to the numbers over here? So when it's figure number 1 is 1 square. When it's figure number 2 is 2 square. When it's figure number 3, which is 3 square. When it's figure number 4 is 4 square. So when it's figure number n, which is n square. So let's look at the number of white unit square. So for the first term, it's 3. The next one is 5. The next one, so you notice, right, for each figure number, what is the rule for this case? You notice there is plus 2 for the first one. For the second one, there are 1, 2. For the third figure, there are 1, 2, 3, 4, 5, 6, 7. 7 square. The next one is 9. So you notice that there's a common difference of plus 2. So you count plus 2, plus 2, plus 2. So to find out, so how do we find out the number of white unit square? So one way is you can express the number in terms of the first term. So 5, right, is equals to 3 plus 2. 7 is equals to 3 plus 2 plus 2. 9 equals to 3 plus 2 plus 2 plus 2. So you notice how many 2's are there when we increase the when we're looking at the next figure. So when there are the first term, there's no 2. So I can write as 3 plus 2 times 0. The next one, there are only 1, 2, so I can write as 3 plus 2 times 1. The next one, I can write as 3 plus 2 times 2. And for figure 4, I can write as 3 plus 2 times 3. So this one is the first figure, second, third, fourth. So what do you notice about the relationship between the figure number and the number of sets of 2 we have? So you notice that when it's figure 1, I have 0, 2. When it's figure 2, I have only 1 set of 2. When it's the third figure, figure 3, I have only 2 sets of 2. When it's figure 4, which is the fourth term, I have 3 sets of 2. So you notice that the number keep on decreasing by 1. So that means for my n term, it will be 3 plus 2 times n minus 1. So this is the expression for the n term for the number of white unit square. So since we have this type of expression, this is not the simplified form yet. You need to simplify it further. So I can expand it. So 2 times n is 2n, and 2 times negative 1 is minus 2. So I can simplify it further again. So 3 minus 2 is 1. So I can write as 2n plus 1. So my expressions for the number of white unit square will be 2n plus 1. So let's look at the last column, the total number of unit square. So when it's in the first figure, it's 4 square. When it's the second figure, I have 9 unit square. When it's the third figure, I have 16 unit square. When it's the fourth figure, I have 25 unit square. So when I have the n figure, you notice that 4, 9, 16, 25. Does it ring a bell to you? What is this special number called? So you're right, these are called square numbers. Why? Because we are taking a number and we square it. So if you notice, right, 4 can be written as 2 times 2, which is 2 square. 9 can be written as 3 times 3, which can be written as 3 square. 16 can be written as 4 times 4, which is 4 square. And if I have the n figure, it will be what? So let me write down the position number and let's compare. So when I have the first term, I will be having 2 square. When in the second term, it will be 3 square. When the third term, it will be 4 square. So when I have n term, I will have n plus 1 square. So my expression for the total number of unit square will be n plus 1 bracket square. So now I have found out all the expressions for the length of set of large square, for the number of gray unit square, for the number of white unit square, and for the total number of unit square. So part 2 asks us, large square has a length of 65 units. So that means we are looking at the second column, the length of set of large square. So how many white unit square does it have? So let's do it step by step. So for this case, we need to find out which figure are we looking at. So I let this figure be. So I use the length of side of large square expression n plus 1. I equate it to 65 units. So to find out what is n, which give me 64. So this tells me that this figure number that we are looking at is figure number 64. So since we know that n equals to 64, we can use the expression for the number of white unit square, which is 2n plus 1, which is 2n plus 1. Okay, so this statement you don't have to write. I'm just writing it down so that you can see what I'm talking about. So to find out how many white unit square are there, number of white unit square in the 64 term, in figure 64, it will be 2 times. So I replace my n with 64 plus 1, and this will give me 129. So that means that this figure here, figure number 64, it has 129 white unit square. So now the last question, last part 3. So for part 3, right, they say, will there be a figure in this sequence that has 920 gray unit square? So since we are looking at gray unit square, we will need to look at the expression that tells us about the gray unit square. So for part 3, right, is the last type of questions. Check whether a particular sequence contains a specific number. So in this case, the specific number will be 920 gray unit square. So you equate the expression for the gray unit square, 2n plus 1, with, so the number of gray unit square, the expression will be n square. So you equate it with 920. So you need to find out what is n. So in this case, I can square root 920. So when you square root 920, it will give you this number, which is 30.33150178. So when I know that this n is now not a whole number, what can it tell us? What will be our conclusion? It will tell us that since n is not a whole number, the figure or the sequence does not have 920 gray unit square. So this is how you explain your answer. So when they say explain your answer, after you have calculated the n value, you need to explain how do you arrive at this conclusion. So we know that n is a position of a term. That means it must be whole number. For example, you cannot be running a race, and after that they tell you that you are at the 7.5 position. It doesn't make sense. It's either 7 position or 8 position. There's no like something point something positions. All these positions in a race will always be whole number. So this applies the same for the position in number sequence as well. They all must be whole number as well. So this is it. So if you have any question, please ask. And yep, please ask.